Hey, this video here is going to help you make a lab report. And I was working on one here. I think I'm going to go ahead and delete that. And in your Google Classroom, whatever version of physics you're in, you should have a copy of this document that is called Sample Lab Format. And you're going to use that document to help you make a lab report. So we're going to go through that process here. I'm going to show you what to do and also try to convince you that it's really pretty easy and can be a pretty painless and not too time-consuming process to do that. So the first thing we need to do is you need to actually do a lab and have some data. So I did that, and I think I dropped, let's see. Here we go. I took this little golf ball. It's a yellow golf ball, Titleist, and I dropped it from a bunch of different heights. And at some point, if you just kind of scan through your lab report format here, you can see that we're going to need to put a data table in. So I'm going to go ahead and from my Google Drive, I am going to make a new document. And I'll give it a title. Let's see, this is, what would be a good title for this lab? How about bounce height of a golf ball? That's pretty good. I'm going to make that into a title. Let's see, so I'd like to make that look like a title. How about that? All right, and center that. You know, I don't want you to spend too much extra time worrying about what your document looks like, but it does matter. I mean, you don't want to make a nice document where the content's great, but the document looks like crap. You know, that's just kind of a bummer. So let's see. At some point, I'm going to need a data table. So I'm going to go ahead right now. You don't have to do this out of order like I'm doing. But I want to insert a table. And I'll tell you what I did. I took this here golf ball and I dropped it 7 times from 7 different heights. And then I used a meter stick, which I taped up to the wall to see how high it bounced each time. So that means if I'm going to put little titles at the top, 2 by 7 would be good, but I think I actually need a 2 by 8 because I would like to put titles. So what I did was I picked some different drop heights that I measured in centimeters. So I'm going to put the name of my variable and then the units here. And I dropped it from 10, 20, 30, 40, 50, 60, 70 centimeters. And then I measured how high it bounced. I'm going to call that the bounce height. And I measure that also in centimeters. And I wrote those down somewhere. See if I can find them. Got it. So let's see. What did I get? I got 6 and 14 and 22 and 30 and 36 and 43 and 50 centimeters. All right, now I don't really like the way I've got a ton of room here in these columns that I don't need. So let's see if I can tighten these up a little bit. That looks better. And same thing here. That looks pretty good. If you want the things in your table to be centered, we could do that. Would like them to be centered. There, that looks nice. Okay, I'm happy about that. Now there's going to be other stuff in here, so make some more room. Let's see. Let's just jump in and start putting that other stuff in. So according to my sample lab format, see how I'm doing. Oh, I'm supposed to put my name at the very top. So let's go in and do that. And get back to justified left. And I don't want my name to be gigantic, so let's type my name as Chris McGrath. And who are my partners? Say my partner is named partner, and maybe I have more lab partners. And then I want to just go ahead and make this all the same font size. There we go. That's better. Okay, looks good so far. Now, what do we need next? Sample lab format, I need the purpose, which must be stated in terms of the IV and the DV. Well, maybe I'll do those first then. So let's see. I'm going to need a place for my purpose. But before I do that, I'm going to state what is the independent variable and what is my dependent variable. My independent variable, that's the thing that I'm controlling, right? That I have control over. And what I was controlling there, I was controlling how high I drop the ball from. So that is going to be my drop height. And from here on, I might sometimes abbreviate that, DH for drop height. So we'll see. That could come in handy. And then the thing that was changing because I was changing the drop height, well, that was the bounce height. And call that BH in case we want to abbreviate. All right, so what's the purpose? The purpose of this lab is to investigate how, now here, this variable, the second one here, my dependent variable, it depends on the first one. So all I have to do to write the purpose is just state that we're trying to figure out how does it depend on that. So how the bounce height of a golf ball depends on the bounce height. To investigate how the bounce height of a golf ball depends on the bounce. Oops, just kidding. Depends on the drop height. All right, that's my purpose. You can make these little title things bold if you want. Doesn't matter too much to me. Okay, so let's see, what's next? The apparatus. I can put a picture of the apparatus. So how am I going to do that? Well, let's see. In this case, how do I do the picture? Let me see if I can do this real fast for you. I've got the ball. I also used a meter stick, and just in the interest of time, I'm not going to take the meter stick, but I would do that if I was doing this for real. I would do that. Now, I am just going to go ahead and take a picture of that with my phone. Click, got a picture, and then I'm going to send that picture to my school email. So, mail. You might have the option. I have my phone is also has a different Gmail account connected to it, so it might get a little confused. But it does have the option to go directly to your Google Drive. So you could try that. Also, I'm just going to email it to myself, and then I'm going to go to my Gmail and wait for that to come through. Nothing yet. Takes a minute. Oh, nope, just kidding. It's waiting for me to decide what size I want. I'm just going to go with the small size. Now it should be coming through. And there we go. There's my image. And I'm going to add it to my Google Drive. And then I'm going to go back to my document here. And I'm going to type apparatus. And I'm going to insert an image. It's from my Google Drive because that's where I put it. And it's the most recent thing that I did. So if you have the recent tab up on your Google Drive and you're doing it kind of like what I'm doing here, it should be super easy to find because there it is. It's the most recent thing I did. So I'm going to click that and insert. All right, now that is a pretty gigantic picture of the little golf ball there. I really don't need it to be that big. So I'm going to click on that and grab that corner and squish it up so it doesn't take up so much space. There it is. And squish it up even more. If this was a real lab, again, I would want to make sure that in the picture I had all the stuff that I used. And if you're wondering, well, what stuff am I ever going to use, Mr. McGrath? Because I don't have a physics lab at my house. I'll let you know what you need to do there. So no worries. And if need be, I'll send you a picture that you can use. Okay, so there's my apparatus. What do we got next? I think I got to do a procedure. So complete sentences describe how you collected your data. I don't really want to write a whole procedure here. Let's see how we can do. But I do want to emphasize that what you need to do in the procedure is very clearly articulate how you collected your data. Clear enough that somebody else who has not done this with you would be able to reproduce what you did. So procedure, step one, you could say get the materials, which in this case is a golf ball and a meter stick. And then we're going to drop the golf ball from 10 centimeters and we can't just say measure where. I mean, how are we going to measure it exactly? How are we using the meter stick? And approximate, let's say this. How about this? Measure approximate. I'm saying approximate here because I mean the ball's going to be bouncing up and down. It's all going to happen pretty fast. So I'm going to do my best to see where it bounces to. Bounce height of ball say making sure that the observer's head is level with the bottom of the ball. So whatever, I mean, that's just some detail about how I did it. I just made sure I dropped it once from each height, and then I kind of got an idea where it's going to bounce to, and then I got my head at that level, and then I dropped it again from that height, so I felt like I was at the right height, and then I looked at where the bottom of the ball was, with level with the bottom of the ball. Okay, that's good. So record the bounce height. Okay. I can use this abbreviation bounce height because I defined it earlier. That's fine. And then repeat. Step 2, increasing the drop height by 10 centimeters until 7 measurements have been obtained, or something like that. You get the idea. There's not really much else to say. That's what I'm doing. That's how I'm getting my data. So that's good. And then let's see what's next. Need my raw data. Now, if you look at this little template here, it says there's raw data, there's a place for that, and there's also a place for calculated data and a sample calculation. And what the heck is that about? Well, we're not going to do that in this lab. We're not going to do that for a while. So right now, I'm going to just punt on that, and I will tell you that we'll talk about it when we need to talk about it. So this is just my data. Since there's no raw data, there's no difference. I just have data, not of 2 types. So I don't need to have multiple titles or more than one word. It's just the data. Okay, so what I'm looking at now is I really do not like the data table to get split up over a page break. So I can either try to figure out how to get it back up onto this page, which it looks like there should be room. Oh, so close. Oh yeah, did that do it? No, so close. Dang it. Well, okay, so you can try that. Try adjusting things. I guess I could tweak my picture. That should do it. Yeah, there we go. Okay, so it's all on one page. If you can't do that, then even if it leaves a big white space, just go ahead and tab it down until it's all on the same page. I know this is all electronic. It's not like you're going to have a printed copy in your hand, but this right here is better than having it broken up. Now, in this case, we did actually fit it all onto one page, so back up to there. All right, we're good. So there's our data. And the next thing we need is not to be in the footer. No, don't want to do that. Let's see. It's not letting me get out of that table. I need to click down here. There we go. Okay, down here. So the next thing I need is a graph. Okay, so I'm going to go into Graphical Analysis, and I've already done this here. How did I do all of this? The drop height, when you double click, oh, sorry, that's how Logger Pro works. Column options, you can put your title in and your units, and then don't have to worry about that, at least not now. So same thing, you put that in. I typed all my data in. It came up in the graph. I clicked on this here. I went to the edit graph options, and I made sure that on both the X and the Y axis that I had always show 0. Whenever possible, we would like to have that always show 0. Points, lines, or both. Why not both? What does it mean if you do lines? The lines option, it does this sort of connect the dots thing between your points, and that is not good. Don't like it. Both, no thank you. Just want points. And that's good. Then would also like to apply curve fit. That's how I got that line of best fit. And the very first option that comes up is linear. This looks like a straight line, so that's your option here. But you can do other things, including also in this one, what is a proportional fit? Well, a proportional fit is also a linear fit, but it's a linear fit where the line has to go through the origin. How do you know if you should do that or not? Let's look at this. This, if you look at the Y-intercept of this, it's pretty small, and it looks like it comes pretty close to the origin. Now, should it go through the origin? Or should it not go through the origin? Well, what would it mean for it to go through the origin? We're getting a little ahead of ourselves and talking about the meaning of the Y-intercept here, but I think we can think about that for a sec. Should it go through 0? If it does go through 0, that means the bounce height is 0 when the drop height is 0. Or in other words, if you drop it from 0, the amount of bounce you get is 0. Does that make sense? Sure, it makes perfect sense, because if you drop it from 0, that's like not bouncing it. How high does it bounce when you don't drop it? It doesn't. So that makes sense. So in this case, we should actually do a proportional fit, which is the really very, very, very first option. And then apply that. It looks like it kept the other one. So I'm going to slide that down, get rid of the linear one. Okay, that's good. So now, got my nice proportional fit, get rid of that. There we go. Tuck that down into the corner. Okay, so it's telling you that the equation is y equals ax. If you're using Logger Pro does a little bit better job of helping you out with the equation. This just tells me y equals ax, where a is 0.72. So, all right, let's get this into the graph, then or into our report, and then we'll talk about the meaning of the slope and all that stuff. How do you get this graph into your lab report? Like this. On a Chromebook, if you push Control, Shift, and then in the very top row of keys on your keyboard, there's a key that looks like a rectangle with 2 lines to the right of it. It looks like this. Can you see that? That's my date. There it is. it looks like this right here. It's right in the center of the top row of your Chromebook. So if you hit down Control, Shift, and that key at the same time, hit them all at the same time, then your cursor, now notice how the mouse has turned into these crosshairs. And then I'm going to go up to the top corner here, and I'm going to click and hold down the pad and drag over my graph. Make sure you include all the important bits. Don't cut off drop height, for example. All right. And then at the bottom of this now it says copy to clipboard. I'm going to click that. I would like to do that. What that means is now if I go back to my Google Doc and I hit paste or Control V, boom, there's my graph in my document. Nice. It's got a title because I put a title on it. That was also in graph options. It's got the right labels on it. All good. Okay. Now, the next thing I'm supposed to do in my sample lab format is say what is the mathematical equation for the graph, the meaning of the slope, and the meaning of the y-intercept. Okay? So the mathematical equation is, this says y equals ax, but there's no y's and x's in this. The y-axis is bounce height. So my equation, let's see, I need to insert an equation. My equation is bounce height is equal to this fraction, this number. It says it's 0.72 is the slope of this. Okay, 0.72. Let's see. But that number in physics, everything has units, right? I mean, it's not just a number. It's like something about measurement. So 0.72 what? Well, it's rise over run. The slope is rise over run. So the rise is bounce height measured in centimeters. So this is, I'm going to go to my equation editor here, which you can get by going to Insert and Equation. I'll bring that up. So I've got to put a fraction. Oh, not on that side of the equal sign. So bounce height is equal to, and then I'm going to go in here, see if I can get. All right, Chromebook is not really cooperating here. If you're using a your own computer and it's a PC, all right, it's starting a new equation for me over there. We can deal with that. So A over B. Then to get into the equation editor, you can hit, let me look at a keyword. I think you hit Shift, Alt, and the equals and plus key. Shift, Alt, equals. And I think that gets you into the equation editor. If that's not it, it's something Alt equal. It could be Control Alt equals. And the equation editor in Microsoft Word is way better than the Google Docs one, just telling you. So 0.72, what do we have? Centimeters. How do I know it's centimeters? Because this is rise over run. The units of rise, right here, boom, centimeters. That's units of rise over units of run. And I don't want to change the number, so I'm just going to put a 1 under it. Okay. I do the same thing every time I do a slope, just like that. And that's times the drop height. Oh, I want that to be in my equation too. I guess I could just make a new one by doing Control-Alt, screeny thing. Didn't work. Control, wasn't that it? Control-Shift, screeny thing. There it is. Nope, no, that's for doing a screenshot. Sorry, I need to do insert. That's what I need to do. Insert. And I did take a screenshot, and I don't want to. I'm going to X out of that. Insert an equation. I can get back to there. All right, so now I've got drop height. So this is like my y equals mx. And if I did have an intercept, it would be plus b. But we decided it should be 0. All right. So what is the meaning of the slope? This is a big deal, folks. You need to know how to state the meaning of the slope, and you have to understand what it means. It's really easy to do if you wrote your equation well. All you have to do is read the slope upside down from bottom to top and say that for every one of these, you get this many of this. So the meaning of the slope for me, for every 1 centimeter of drop height, there are 0.72 centimeters of bounce height. Yikes. Height. That is the meaning. Let me just check this off real quick. Sorry, that was our afternoon announcements. Might get interrupted by a bell here in a second, but that's okay. So let's see. That's good. The Y-Intercept. What is the meaning of the Y-Intercept? The Y-Intercept is, we're going to state it the same way every time. It's basically when there's 0 of this, it's how much of this you get. So the Y-Intercept is here. It means when the drop height is 0, the bounce height is 0. And then, you could add a comment here, which means in more plain language, you could say, if you don't drop the ball, it doesn't bounce. All right. And I think the last thing for us to do is our conclusion. So conclusion, it looks like we want to do 2 parts here. You can number them 1, 2 like this, or you can put it all together if you want to. I suggest that you number them and do the 2 parts of it, or 2 little paragraphs. So part 1, written explanation in complete sentences of relationships discovered. It must address the purpose, and you have to restate your mathematical equation. So let's see if we can do some version of that. So this is my conclusion. I'm going to just do it as 2 separate paragraphs. So the first part of the conclusion is I'm going to write, in this experiment, we set out to find how the bounce height of a golf ball depends on the drop height. All right, good. We discovered that the golf ball bounces 0.72 centimeters for every 1 centimeter of drop height. Notice that I'm restating here. That's the meaning of the slope. I don't think I need to restate that you don't drop it doesn't bounce thing. That's kind of obvious. So we discovered that the golf ball bounces 0.72 centimeters for every 1 centimeter of drop height. The equation, I like to call equations mathematical models. The mathematical model for this experiment is, and then I've got it right here, so let's see if we can just copy this. Paste that there. Good. All right. Doesn't have to be a super long conclusion here. Just need to say the right stuff. In general, this is the part that's a little trickier. So can we generalize this result? In general, we might expect that different balls would have similar mathematical models, or in other words, equations. But what would be different? So what would be the same and what would be different about this? I think the thing that might be different, we might expect that it would still be some kind of proportional relationship, but maybe it would be like more or less bouncy than the golf ball. So maybe like this particular number would be different, but it would still be an equation like that. We might expect that different balls would have similar mathematical models, but with a different slope. In general, we think that the model, let's see, the general model would be, what would you call that? Like we have to pull this out. It would be like some number, right? It would be just like some, what is that? I guess if the number was bigger, then it would be like a bouncier ball. And if the number was smaller, it would be a less bouncy ball. So how would you describe that? It's like the bounce factor or the bounciness number, the bounce factor times the drop height. Something like that. So that's the game. That's how we're going to play physics. We're going to collect data, try to come up with a mathematical model, and then we're going to try to generalize that model and see if we can use it to do stuff. So here's an example, and you can use that as a guide to making